Okay, ladies and gentlemen, this is a revision lesson for electrostatic, static electricity. So I want us to do the revision for static electricity. Static electricity. This topic has got three definitions, which are examinable. Three definitions. The first one is just to state a law. You need to be able to state Coulomb's law, right? Then the second one is electric field. Third one is electric field on a point. So you need to go and check these three. One of them will be examined, right? Yes. So there were three definitions. Well, good, right? Yes. So now I'm erasing these definitions, which you need to go and check. Since this is a revision, go and check Coulomb's law, electric field on a point. Don't use your beautiful textbook for definitions. You use an exam guideline. Go to the exam guideline, check for the definition as it comes from the exam guideline. Don't use a textbook because some of the things in our textbooks they are not KEBS compliant. So most of the textbooks are not 100% KEBS compliant. That's why I have given you the exam guideline. So please kindly go and use the exam guideline to check this. Now we're starting with the revision. As far as this topic is concerned, we're going to come across the letter C. The way I teach is inspired by Mr. Nechapara. You don't know him. We're going to come across the letter C, which stands for Coulombs, right? Letter C in this topic stands for Coulombs, right? So the first thing is to remember to master the language that you use. We're going to come across letter C, which represents Coulombs, right? So the problem that comes sometimes, you find that they wrote 2 and C. This C stands for Coulombs, right? Then you find that they wrote 2, I will call it UC, but this thing is in italics, right? That symbol that we use for a coefficient of static friction or what, that you see that one. So we need to know what does it mean, because if you are given 2 charges, you will just represent the first charge with the 2 and the other charge with this 2, and it is wrong. Let me make this one to be 3. So the first thing we must know, what does this N represent and what does this U represent? As I am telling you that this U is, I'm just calling it a U because of how it is written. It's a special symbol, right? So this N is stand for nano. So this one, it means it's nano coulombs. Coulombs, right? It's nano coulombs. Then this U, it means it is micro coulombs. It is micro coulombs, right? We know we have data, we have we buy gigabytes, we buy megabytes, those terabytes, those things, it's a number. They are represented by what? By numbers. So nano coulomb, it's one of the smallest units, right? It's one of the smallest units. So what does nano mean? Nano means 10 to the power minus 9. Nano means 10 to the power minus 9. Meaning that if you are given 2nc, what does it mean? It means it's not just a 2. It means it is 2 multiplied by 10 to the power minus 9. We need to remember that this n stands for nano. And nano is 10 to the power minus 9. Then, what about micro? We've got 3uc. So, what does micro represent? What is the number for micro? Micro is 10 to the power minus 6. Micro is 10 to the power minus 6. So we're mastering the language. You need to remember the language. So it means we're going to come across MC and UC. We need to remember that whenever we see 3UC, U for micro, right? So we know that it is 3 multiplied by 10 to the power minus 6. We've mastered the language. We're good, why? We're fine, right? So they're going to use a number, the right? Negative 4. Negative 4 UC. You need to know that whenever they use micro, micro is what? Is 10 to the power minus 6. We're good, all of us. Okay. No one have a question, right? Yeah? Do you? Okay. Wow, progressive. We've mastered the language. We've mastered letter C, columns, U, C, micro, columns, and NC, nano, columns, right? We're good, right? Yeah. Okay. Then let us talk about Coulomb's law. Coulomb's law. Let us talk about it. Coulomb's law, mathematically, you see, I think maybe this guy was used to copy people's things. Okay. Let us talk about Coulomb's law. Coulomb's law is given by F, which is equals to A Q1 multiplied by Q2 over R squared. Then this, as I usually tell you, that in order for you to state a particular law for physical sciences, what you need to do, you go to the formula sheet and the formula sheet will tell you, right? Yeah. So this F, it is called electrostatic force. So whenever you find a question requesting you to calculate the electrostatic force, it is talking about this F. This F in this topic, it represents the electrostatic force. If you hear something electric field, what? It is not this one, because this one is electrostatic force. You hear me? Yes. Then this K, you see this K? Yeah. K is a constant. It is a constant. It is there in your data sheet. We provide you with a data sheet which will have a K. K is given by 9 multiplied by 10 to the power 9. You know, we are dealing with a lot of negative powers here. Don't go and ignore that data sheet. It does not have a negative. It's a positive 9. Can you see that? Yeah. So that's K. Then Q1 and Q2. What is Q1 and Q2? Q1 and Q2, let's say we have two spheres, right? Yeah. And it has got a particular charge, and this one has got a particular charge. It means Q1 and Q2 is the charge of sphere 1 and charge of sphere 2. So Q1 and Q2, these are charges on these spheres, right? Yeah. So what does R squared represent? R squared is the distance between the two spheres. So the distance between these two spheres, let's say, is 0.5 meters. It means we're going to write 0.5, then we square it, as the formula states. You can see, right? Yes. The relationship between the force and the distance between the two spheres, you know it's what? It is inversely proportional. When this distance increases, it means the electrostatic force will decrease. When the distance decreases, it means the two spheres are coming closer to each other. It means the electrostatic force will increase. It means we'll have a stronger force of attraction, you understand? Yeah. So that's the relationship. Okay. I saw another question. They say, here they put woods. They say that, why are they putting the spheres on a wood? If they were to use an iron there, what will happen? An iron, it can conduct electrical charges, meaning the electrons from this sphere, they can do what? They can leak. They can move to the iron, right? Since it can conduct electricity. Yeah. So they are using woods to put these spheres to insulate as an insulator. You know what we mean by insulator? It's to prevent leakages, right? Yeah. To prevent the flow of charges. So by using woods here, that's why we have a special type of plastic on our electrical cords. We have a special type of plastic on our electrical cords because their work is to what? Is to insulate, right? To prevent charges from leaking. So that's why they are using a wood. I told you now, right? We're good, So that's why we find that they are using woods is to insulate or to prevent what? The charges from leaking, which they are actually talking about the electrons, because protons, they do not move. Only electron moves. We're good, right? Yes. Okay, I've explained that K is constant. Q1 and Q2, these are charges on sphere 1 and sphere 2. R squared, it is the distance between the two spheres. So, let's just explain Coulomb's law. Coulomb's law in terms of this, because this is Coulomb's law. What does it say? It says that the magnitude, which is the size, right? The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitude of the charges, right? And inversely proportional to the what? To the distance between the two. Okay. I want you to master what is happening. Magnitude, it means the size. It's like if I have a 3 here. If F is equal to 3, by magnitude, I mean that's 3. It's the size, right? So, what does it say? It says the magnitude means the size, right? The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitude of the charges. Let's check this. This charge is -4 UC. Then this one is 8 UC. What does it mean? It means that the magnitude of the electrostatic force exerted by this point charge on this point charge is directly proportional to the what? To the product of the 2 point charges, and inversely proportional to the distance between the 2 point charges. As I told you that the electrostatic force is inversely proportional to the distance between the charges, right? Yeah. I told you that as the charges they move away, the force of attraction here, will it be high or low? It will be low because the charges are moving far apart, right? Yes. But as we bring the spheres closer together, will the electrostatic force of attraction, what will happen? It will increase, right? So it is true, it is not difficult to know Coulomb's law. You just draw this and you say what you can see from the formula. The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the magnitude of the the product of the magnitude of the 2 point charges, and inversely proportional to the distance between the 2 point charges. We're good, right? Yeah. I've explained Coulomb's law. So now, when do we use this Coulomb's law? When do we use Coulomb's law? The main point to note, you use Coulomb's law when they say calculate the electrostatic force which A exert on B. When they say calculate the what? Electrostatic force which A exert on B. It means we are going to have what? We have two charges, right? We have two charges, Q1 and Q2. You use electrostatic force when they say calculate the magnitude of the electrostatic force which B exert on A. Already when we have A and B, already we have the what? The distance between the two. You understand when we apply this electrostatic force, right? We'll deal with the question. Now we're still revising the content. When do we use electrostatic force? When they say calculate the magnitude of the electrostatic force which A exert on B. They will never talk about a point there. They will never talk about electric field there. They will talk about 2 point charges which this one exert on this one. You understand, right? So take note of that. Okay. Sometimes the question can come like this. Can come in this fashion. Sometimes the question can come in this fashion. So, now, you find that we've got a sphere 1 here, right? And a sphere 2. They are put on the wooden block. Then, they introduce the third sphere. We find that this one is -4. It's -4 UC. We know this is not just UC. This is -4 multiplied by 10 to the power minus 6. Because I told you in the introduction that UC is micro. Sometimes they can write MC, which is nano, which is 10 to the power minus 9. So you find that this one is -1 UC. Then this one is 8 UC. Then they say calculate the net electrostatic force which you find this one, let us call it C. This one is A, this one is B. Look at the question. Calculate the net electrostatic force which C experienced due to A and B. You see, now we have a problem because the formula in our formula we have Q1 and Q2. We don't have Q1, Q2, Q3. Hey, Zakala, get mind. It's tough. We don't know what to do, right? But let us listen to the question. The question will request us to calculate the net electrostatic force, right? The word net, it means the sum of the total. Net. It's all that. It is like summing everything, all the electrostatic forces, we sum them, right? So when they say calculate the net electrostatic force which C experienced due to A and B, you know what to do. You use this formula to calculate the electrostatic force between A and C. You understand? You use the formula to calculate the electrostatic force between A and C. Then you get the answer. Let's say you get 0.5. And right? Then you come here. What do? You calculate the electrostatic force between C and B. You get the answer. 0.6. I'm giving you an example, right? You find that this one is to the left, this one is to the right, or both of them are going to the left direction. Then you do what? To get F net, what do? You add this electrostatic force and this electrostatic force. It means you get electrostatic force for AC plus electrostatic force for CB. Well, good. Then you sum them. It means you got the net electrostatic force. Did you see? Sometimes you come across a question which will request you to calculate the net electrostatic force. So it means what do you do? If you have 3-point charges, you calculate the electrostatic force between these two. And you calculate electrostatic force between these two. Then you do what? You sum them. They will give you the electrostatic force that C experiences due to A and B. Did you learn?
Yes.
So, sometimes they can do worse. Sometimes they can do worse. They do worse by bringing those things on a triangle. We find that we've got the point charge here. We've got the point charge here. We've got the point charge here. Can you see? Then they give us a distance. They give us a distance. You understand? So what do? You do the same thing, right? You can even use Pythagoras theorem, whereby you calculate the what? They say calculate the electrostatic force. Then you calculate the electrostatic force between this one, between A and B. Then you calculate the one between C and A. If you want to get the resultant electrostatic force, what do? You use Pythagoras theorem. Isn't it? This is a triangle. It means the resultant for these two. Which one is the resultant for this one? It's this one, right? So what do? You use Pythagoras theorem. You calculate the electrostatic force between these two. You get it. Let's say you get 0.06, right? Then you calculate the electrostatic force between 1 and 2, you get 0.07. If you want to get the resultant, what do? If you want to get the resultant, you use Pythagoras theorem. It means the resultant square is equals to 0.06 square plus 0.07 square. Then you will get the electrostatic force for this one. Because the problem about here, you don't have the distance between A and C. So you cannot use this. You better use Pythagoras theorem to get this one because you are not given the distance. You understand? Yes. Okay. We are good, right? Okay. So now we can move, right? We can move. Okay. Sometimes, guys, in multiple choice, you come across a situation where they tell you that if we were to double the charges, what will happen? If we were to double charge 1 and charge 2, what will be the electrostatic force? If we double the charges, right? What does doubling mean? If we double Q1 and Q2, what will be the result? Sometimes they give you 1 over 2F, 4F, 2F. You don't know which one to choose, right? Let's just do something like that. Let's say we have F, we want to double. When we double, it means we'll have 2Q1 and 2Q2 over R squared. Isn't it? This is doubling. Yeah. To double something is to multiply by 2, right?
Yes.
Then we'll have F is equals to K, 2 multiplied by 2 will give us 4Q, Q1 and Q2 over R squared, right? Yes. Then we take 4 to be here. Then we have K, Q, Q1, Q2 over R squared. This is equals to what? This is equals to F, right? Eh? So meaning that I can remove this F to avoid talks because this is F is equals to F because K, Q1, Q2 over R squared is F, right? So it means we're going to have what? 4F. You see where the 4F come from? So when they say double, just double and you try to work on it, then it will give you an answer. Don't claim that it is 4F because the question may come in another way. They say we do what? Maybe we add half or we do whatever. So don't claim. I'm trying to make you understand when multiple choice question comes, you must do what the question says, then you solve it. It will lead you to an answer. You understand, right? Yeah. Okay. Well, good. So now let us do this, which is very important. Okay. Sometimes they tell you that we have got sphere A and sphere B. This sphere A and sphere B, they've got charges of equal magnitude. Do you hear the question? Yeah. This sphere A and sphere B, they've got what? Charges of equal size. Right? Yeah. They've got the same charges. So they want you to determine the charge. They want you to determine the what? The charge, that charge. Charge A and charge B, they've got the same charge. They give you that the electrostatic force between the two charges is 0,07. The electrostatic force between the two charges is what? 0,07. I'm just making these numbers for me to revise with you well, right? Yeah. So this is not real. I just made up this number. They were given what? Two spheres, but these spheres they've got the what? Same charges. It means the charge that is here is equal with the one that is here, right? The electrostatic force between the two charges is what? 0,07. Then the distance between the two charges is 0,001. They say calculate the charge. What do you do? They say calculate the charge. Here is what you need to take note of. F is equals to K. Q1, Q2 over R squared. Right? F were given, which is the electrostatic force, right? Yes. 0,07. This is where people make a mistake. Q1 and Q2, this time around, they are the same, meaning that we are going to have K multiplied by Q squared. K multiplied by Q squared. Look, you see Q1 and Q2 here in the formula. It's like having X and Y. They are not the same, right? But if they say that we have what? We have the same charges. It's like we have X and X, whereby X and X will give us X squared. So be careful about that. So some of you get to write, you write 2Q, which is wrong. They are saying charge 1 and charge 2, they are the same, meaning that it is X and X. And X and X, when we put them where there is Q1 and Q2, we're going to have what? We're going to have Q squared. You understand? Then we divide by the distance between the two and we square it 0,01 squared. Then we solve for what? For Q squared. It's a good revision, right? Yes. You see the problem that you make? Yes. They say two spheres. They've got charges of equal magnitude. Then find the charges, those charges. What you do? You do what? You say it's like X and Y for Q1 and Q2. I'm sorry, not X and Y, X and X, because they are the same, right? X multiplied by X will give us X squared. Then you work it out until you get Q squared. So the common mistake that you make, you guys get to write 2Q, which is wrong. You understand? Okay, so we will continue. We can break. You out there, don't forget to subscribe, share the videos with others. Thank you.